Hello everyone, this is the first lesson recording for IM1, November 20th, 2020. So last 15 minutes of the class will be the quiz number 6. So if you missed it for whatever the reason, you need to contact me as soon as possible to arrange a time to make up the quiz. What are we doing today? We are going to demystify fractions. I find that a lot of students, when it comes to fractions, as soon as they see fractions in the problems, they just get really nervous. Fractions are just numbers, and hopefully by the end of today, you're going to feel a lot more comfortable with fractions. But before we get into that, we started off with warm up that reviews how we use line of best fit and the equation we are given to be able to interpret what's going on, as well as be able to interpolate, extrapolate, that means predict numbers for a given set of data. All right, so please pause the video and see if you can do the problems yourself. Here we go. Let's start with the first problems. Okay, so let's read about the situation. The average amount of electricity consumed by a household in a day is strongly correlated to the average daily temperature for that day. So electricity consumption is on the y-axis. The temperature for that day is on the x-axis. This relationship is given by y is equal to 0.479x plus 5.74, where x is the temperature in Fahrenheit and y is the amount of electricity consumed in kilowatt hours. What does the slope of the line represent? Okay, remember the slope is always the same thing as unit rate. That means how much does the y change every time x changes by 1 is what a unit rate tells us. So that means what is the slope? How much does electricity change when the temperature changes by 1 degree in Fahrenheit? So it's really talking about the additional electricity consumption for each additional degree of Fahrenheit in temperature. So what does the y-intercept of this function represent? Y-intercept in this case is this number without the x in front, right? So this number without the x is the y-intercept, and y-intercept is where the graph crosses the y-axis. And where does the graph cross the y-axis? Always when the x value is 0. Okay, so we are talking about the y value when the x is 0. That's the y-intercept. So that means the average electricity consumption, the y value for a daily average temperature of 0 degrees. So when x is 0 degrees, what is the electricity consumption? That's what the y-intercept is telling us. Okay, so then C goes on to using this model, how much electricity would be consumed if the average daily temperature was 60 degrees Fahrenheit? Round your answer to the nearest kilowatt. So let's talk about what are we trying to find and what are we given. So how much electricity would be consumed? That's the question, isn't it? So that's what we're looking for. And electricity consumed in kilowatt hour. It says Y is electricity consumed in kilowatt hour. So that means in this case, we're looking for Y. Okay? But what are we given? We're given if the average temperature is 60 degrees Fahrenheit. Temperature is 60 degrees Fahrenheit. Okay, what are we told here? Where X is the temperature in degrees Fahrenheit. You can also see it in the graph as well. What is the x-axis? It's the temperature. So x-axis is the temperature and the y-axis is the electricity. Okay, so that means temperature, that's the x value. Here, we can say x is equal to 60 and we're trying to find y. Well, we're given the equation. Yes, you can certainly find it from the graph, but that's only a very rough estimate, while as the equation is there for us that we can use really precisely. So that means when we're given the equation, you use the equation. So for x, we know x is 60. So whenever in this equation, we substitute 60 as the x value here, and we're trying to find y. So the equation becomes y is equal to 0.479 multiplied by x, which is 60 plus 5.74. And when we use the calculator, I get 34.48. This is already to the nearest, the answer to the nearest kilowatt hour. That means we want no decimal places. Okay, so that means we want it rounded off. We want to cut it off at the decimal place. Okay, but before we cut it off, we need to consider the next digit that comes after where we're considering to cut off. If this number is 4 or less, then we leave the number as it is. If this number is 5 or more, that means you need to round it up. In this case, it's 4. That means it's 4 or less. That means we leave it as it is. So that is going to be 34, and the unit is kilowatt hour. Okay. All right, then let's try the next problem. According to this model, how much electricity will be consumed? Again, how much electricity will be consumed? That means we are trying to find why electricity consumed, that's the Y value. That's what we do not want to find out. If the average daily temperature is 99 degrees in this case, okay? So it's 99 degrees. Looking at this, we don't have any data for 99 degrees. So that means we are predicting outside the data value that we have. So this will be called extrapolation. And we know that the temperature was 99. So X in this case is 99. So it's very similar to C. We are just basically substituting for X to be 99. So you're using the equation because that's the computer has already done that for us. Okay, so and when I use the calculator, I get 53.161. And again, it says to round the answer to the nearest kilowatt hour. That means kilowatt hour. That means we do not want any decimal places. That means right at the decimal place, we are going to cut it off. But before we cut it off, we need to consider the next digit. It happens to be 1, which is 4 or less. That means we leave it as it is. So this is just 53 kilowatt hour. Okay, last problem. What temperature? What temperature? Now, this time we are being asked, what is the temperature? What's the temperature? Temperature is on the x-axis as well as it is, we're told here, x is the temperature. X is the temperature. That means we're looking for temperature. So we are looking for x. Would it need to reach in order for 42 kilowatt hour to be consumed? Now, what is this value? 42 kilowatt per hour. You can also look at the units, and that's going to give you a clue. This is we're talking about the electricity, isn't it? Okay, so in this case, we know what the Y value is. Y is 42, and we're looking for X. In this case, we substitute for Y to be 42 in the equation. So 42 is equal to 0.479 X. I need to write the X because that's what we're going to try to find, plus 5.74. Okay, now some of you might be thinking, oh, all these decimal numbers, I don't know what to do here. Well, this is not, the decimal numbers are just a number. So if it was something like this, what would you have done? If you had 42 is equal to, let's say, 5x plus 6. All right, so let's say this was 5 instead of 0.479 was 5x and this was 6. Okay, so let's just pretend it is. What would you do? The first thing we would do is we would try to get rid of 6. Why? Because the thing that was done to x was first multiplied by 5 and then added to 6. So to undo, we do the very last thing that was done to it, which is 6. So we undo adding 6 by subtracting 6 from both sides, and then you, whatever the result, you divide by 5, right? So you, same thing, you would you try to get rid of this first. Adding 5.74, how do I get rid of adding 5.74? You subtract 5.74. Subtract 5.74, that leaves me with, and this goes away because plus 5.74 minus 5.74 is 0. This goes away to 0, and you're left with 0.479x is equal to 42 minus 5.74, and you can use calculator, minus 5.74, and that leaves me with 36.26. Okay, now you need to be thinking about, okay, now we have something being multiplied to x. We don't want that something, we just want the x by itself. So how can I get rid of this 0.479, which is being multiplied to x? What is opposite of multiplying? It's dividing. So we are going to divide both sides by 0.479. And this leaves us with x is equal to, so 0.479 divided by 0.479, that's my giant one, and that cancels out to 1, so it becomes 1x, which is same as x. So you use the calculator and do 36.26 divide by 0.479, and which leaves me with 75.699. Okay, now we want it to round your answer to the nearest degree. That means we don't want any decimal points. So that means we want to cut it off at exactly where the decimal place is. But before we do that, we need to consider the digit right after where we want to cut off. And this 6 happens to be bigger than 4, right? So that means we can't just leave it as 75. This is 75. It's more than 75 and more than half. So this needs to be rounded up to 76. So x is equal to 76. And what's the unit for x? That's the degrees in Fahrenheit. So degrees in Fahrenheit is my answer. Great. Let's change gears now. Let's think fractions. Again, I'm hoping that at the end of this lesson that you are not going to feel as nervous about fractions as you did before. When you think about fraction, the first thing you should be thinking about is pizza, my favorite type of takeout food. All right, because here you have a fraction. 5 over 8 is a fraction. The top number always represents the number of actual slices of pizza you have. Okay, so I have one slice, two, three, four, 5 slices, and the bottom number represents the total number of slices to make the whole. So how many is one whole divided into? It's divided into 8 parts. So this tells me that I have 5 pieces out of total of 8 pieces of pizza. And we call the number at the top numerator and the number at the bottom the denominator. The way to remember that word denominator is you can think of it as down below. Okay, it starts with the d, down below, and denominator. So that's the bottom number. Okay, so then let's talk about what's the difference between mixed fraction and improper fraction. These are examples of mixed fractions, and this is an example of improper fraction. Mixed fractions are mixture of a whole number and a fraction part. Okay, so 2 is the whole number, it tells you, and then this is the fraction part. That means what we have is we have a whole 2 pizza. Okay, so that's 2 whole pizza. So we have all of that, plus we have another pizza that is divided into 5